So in part 2, we will learn about the base rule. This base rule seems to be a very simple rule, but it can be used in diverse ways. So we are going to see in every single way it is going to be used in logarithm. Let's say log to the base b a. The base rule is that it is log of a, whatever the value is, and put the base as a different log of b. So it is log of a upon log of b. Now let's see one important factor in this. If it is log of 12 on 24, so which is equal to log of 24 over log of 12. Now these both numbers have separate logs, so you cannot divide them by a common factor. It is not log of 2 over log of 1. No, that is not equal to this. First of all, remember this thing. But yes, when we will learn other properties where it will be a single log and then 24 upon 12, then you can write it as log of 2. But in case of base rule, base and the value both get the different log, so we cannot cancel this. This is the base rule. Okay, now if I have applied base rule, you can see there is no base now here. So we can put any base, like I can write, let's say another base c, log of c of a over log of c of b. It's not going to change the value of it. Let's see why. If I take it as a different base and value thing and apply the base rule, so that will be log of a divided by log of c, and this is further divided by log of b over log of c, right? This is divided by, right? Now if you remember the simple fraction rule, if a by b is divided by c by d, then we reciprocate the second part and it becomes like this, right? So here I am going to do the same. This division sign is now multiplication and the second part is reciprocated, log of c by log of b. So this is cancelled. Again I am at log of a upon log of b, right? So first, this is the base rule. Second thing, because every number has its individual log, so you cannot cancel it. Third thing, third concept, that you can give any base, it's not going to change the value. This is the proof of this. But if you simply want to see the rule, then okay, apply any base, it's not going to change. Perfect. Now let's see how magically this is used. Let's say you have same base and same value, log of a, right? So it is equal to log of a upon log of a, which is in turn is 1. So if base and value are same, value overall answer is 1. Sometimes we have to just cram certain things after understanding, so that every time we do not have to prove it and we can write the result directly. So if base and value both are same, answer is 1. Now this again can be used magically, but for that we have to learn one more property. Suppose I have some base a and this is b, and this b has some power, let's say square or cube or whatever the power is. Let's say the power is p, right? Then the rule is this p comes here as a factor, and it becomes log of a of b. This again is used in multiple ways and it's literally magical. So base rule and this property both are magical. First of all, let's see how I'm going to use this. For example, I have log of 2 of 8, right? So 8 is actually 2 cubed. So I'll write it as log of 2 of 2 cubed. Now, if I apply this property, this is equal to 3 log of 2 of 2. Now we are here, right? So this will be 1. Now I have understood it and learned it, crammed it, that whenever the base and the value of same, it becomes 1. So my answer is 3. So two very important basic rules while solving logarithms. Okay, now let's see certain questions based upon this. Question number 1. Again, see, it's a pattern because log has so many rules and properties. So we try to understand the pattern so that we can solve it just like a click, right? Now just imagine if I have log of b of a. So I know this can be written as log of a over log of b by simple rule. I am not adding any base over here, times log of c of b. Now in my first log, b is the base and in the second log it's the value. We have remembered this thing that base comes in the denominator. So b over log of c times log of a of c times log of c over log of a. So here base rule is applied for this, here for this, and here for this. So you see every value is cancelled and we come up with 1. Again, don't take it as a question, take it as observation, very important observation. B is base and B is value. A is base and A is value. C is base and C is value. Everything covered. That means you will end up at 1. One important. Take every question as a rule or the pattern you can understand. So take it as a pattern. Remember it whenever you see this kind of situation. Now let's come to second question. Question 2. Let's x of a is equal to y. Right? Some value x, some value y, and power is a. Y of b is equal to z or z, or z of c is equal to x, and my question is find the value of abc. Now a and b and c, they are in the powers, right? So I cannot find the value. So what is the best way? Let's go to the very basic where we learnt about the exponent and logarithmic, like they are inverse functions. So I'll use log. So how can we write it? Log this x times y is equal to a. So what rule we are using? For example, if this is base and power is exponent, and that is equal to some value, then if we convert it into log, it becomes log. This base is the base here. This value comes here, and that is equal to exponents. We have done some questions on depending upon this property in part 1. So you can just go to part 1 and see that. Okay. Now second one again, log. This y is here, this value is here, that is equal to b log c. This x is here, this is equal to c. Now I have abc, right? So if we multiply equation 1, equation 2 and equation 3, when I say multiply 3 equations, that means left hand sides are multiplied with left hand sides and right hand sides are multiplied with right hand sides, times log of y, base y to c times to sit. Now, if you have understood the pattern from the question number 1, so just see how is it working the same way. Here it is base, right? Okay, sorry, this is x. So here it is base, here it is value. Here it is value, here it is base. Here it is value, here it is base. So according to question number 1, it's going to be 1. We know that. We have understood the pattern. But if you have to show your work, like that is a subjective question and you have to show your work every single step, so then you will simply apply the log rule. For example, log of base to the xy is log of y over log of x times log of c over log of y times log of x over log of c, cancelled, 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 is equal to ABC. So that means ABC is equal to 1. See how log helped us to solve it really quickly and easily. Now, let me just clear one more point. Suppose I have log of A of B times log of B of C. Now here A is only base, not value for any of the logs, right? And B is value as well as base. So that means it is not equal to 1. You have to remember it should be base as well as value. Every base must be present as value too, only then it comes out to be 1. Now let's see what happens to this. Let's take it as question number 3. Okay, so that is log of B over log of A, this part, times log of C over log of B. So B is value as well as the base, that will be cancelled. You have to remember this thing. If value and base both are same in a log, they will be cancelled. Now we end up at log of C over log of A. So now I can do the opposite of the base rule, which is log of A of C. Again, if you like to solve simply step by step, that's okay. But if you are a person who loves to find the patterns, so just see B and B both are here, so they will be cancelled, and then A will be base and C will be value. So again I can use it as shortcut. If you don't want to use it, that's totally fine. But if I follow the pattern from here, let's say it's my question number 4, it's log of 2 of let's say 5 times log of 5 of 6, right? So 5 is value as well as base. So how will that be written? Base will be base and number will be number. Log of 2 of 6, right? And if that is the answer, that's fine. But if you have to apply log rule, so here we are. Remember, 6 and 2 have common factor 2, but we cannot cancel it because 6 and 2, they have their individual logs, right? Okay. This question again, third and fourth, I'm taking it as like one more pattern. So my question is log of 4 of 5 is equal to x, let's say, and log of 5 of 6 is equal to y. Find xy. Now if I have to show the steps, okay, we will show it. But if I have to check one answer from the MCQs, both these equations are going to multiply, right? So if I see the pattern, 5 is present as base as well as value, so that will be cancelled. And base is 4 and this is 6. One step, single step question. But if you want to solve it, let's solve it. Okay, so this is, we are doing direct. Now here we are doing step by step. It's just your style, how you want to go with the questions. You want to do direct or step by step. Now xy multiplication, right hand sides are multiplied here and left hand sides are multiplied here. This is log of 4 of 5 times log of 5 of 6. So that will be log of 5 over log of 4 times log of 6 over log of 5 cancelled, and that is log of 6 over log of 4. This is equal to xy. Now we are going to just do the opposite of the base rule. It is already written as the solved one. So I can give 4 as base and 6 in answer. So direct answer and this answer, they are same. Just check your style, go with it. Okay, can I take another example out of it? Maybe. No, that's it. So we can use base rule in these many ways. Now in next class, we will do the properties of log. And what makes this complex? That whenever you learn the new properties, every time you will see questions where the previous properties or rules are also used. So that is a little bit tricky, but we will practice enough so that we can go through it really quickly and easily.